Alright, in this video, we're gonna prove the left side equals to right side using trigonometric proof. So let's start with the cotangent x minus y, and we'll set that equal to cotangent x, cotangent y plus 1 over cotangent y minus cotangent x. So on the left side, we have a cotangent. So think about how cotangent can be in terms of sine and cosine. By definition, cotangent theta is equal to cosine theta over sine theta. So if you have a function x minus y as the angle theta, we can rewrite this as cosine of x minus y over sine of the angle x minus y. So how do we set that equal? So if you look at the top here, we have cotangent x, cotangent y plus 1, cotangent y and cotangent x. Very similar to like a tangent formula, except it's kind of flipped and we have a different sign. So what we can do is to expand out cosine and sine using a difference of angle formula. So starting with the top, we have a cosine x, sine of y. Oh, actually, cosine x, cosine of y plus sine of x, sine of y. So in case it's not familiar to you, you need to remember that cosine of alpha plus beta, or alpha plus alpha and minus, is defined as cosine alpha, cosine beta, minus plus, it will change the sign, and we have a sine of alpha and sine of beta. Okay, so since we have minus here, so keep, since we have minus between two angles, x and y, we need to keep the opposite sign, which is plus. What happens on the bottom? We're gonna get sine of x, cosine of y. Now we keep the same sign, minus cosine of x and sine of y. Now once you have this bar, you notice that we want to get cotangent of y, which means if I divide the bottom equation by sine of y, I'll get the cotangent y, and the sine y will go away and we'll have a cosine. Okay, for now it's not exactly same, but we're gonna divide the sine of y top and bottom, at least to match the cotangent y on the bottom, and on the numerator we have a cosine of y over sine of y that will match with the numerator cotangent y here. So let's just divide all this. Starting with the top, I have cosine of x and cotangent of y. Sine of y over sine over y will be just 1, so plus sine of x. All divided by sine of x over sine of y and cosine y over sine of y. So that gives us sine of x, cotangent y, and sine y's cancel, leaving you with a minus cosine x. Now, if you look up here, we got the cotangent y, but I need to get rid of sine here because I'm not seeing, I have sine of x in front of cotangent y. And not only that, if you divide the top and bottom by the sine of x, we get the cosine x over sine of x. And that also matches with the cotangent x. And if you divide also sine x over sine of x, we also get 1. So therefore, we can divide the top equation and bottom equation by sine of x. Then we get cosine over sine, cotangent x, cotangent y plus 1, because sine x over sine x will give you 1. Sine of x over sine x will cancel, leaving you with a cotangent y, minus cosine x over sine x is cotangent x. And guess what? That's equal to the right side of the equation. Cotangent x, cotangent y, cotangent x, cotangent y, plus 1 cotangent y minus cotangent x. So there it is. Alright, thank you very much for watching my video. If you found it helpful, please subscribe. Thank you very much.